This is 2.3, analyzing graphs and functions. So we're going to look at different parts of functions and graphs and then evaluate them and study the different things that we've done. We're just putting it all together in one lesson. So here I have a function, and I don't have to give you, notice I give you the function and I give you the graph. So I should be able to give you just the function, or I should just be able to give you the graph. Either one of those, make sure you know how to do it either way. So you should be able to answer this question if I give you the function or if I give you the graph. So if I give you the function, then all I'm asking you to do is plug in -1. So literally blank cubed minus 3 blank squared plus 2, and then you put in -1. That's what it's asking about. Like when you put -1 into the function, well, that's -1, -3 plus 2, and you're going to end up with -2. So another way to do this is to look at the graph itself. So if at -1, so when x is -1, that's what it's saying. When x is -1, where is the function? Well, notice the red function is right here at -2. So that's the point, -1, -2. So at -1, it's at -2. So at 0, I think it's easier, by the way, to look at the graph. So at 0, so when x is 0, where is the function at? Well, at 0, when x is at 0, notice the function is right here. So 0, 2. So it's at 2. At f of 2, so when 2 is x, where is f of x? Well, it's right down here at -2. So again, the point 2, -2. 2, -2. So again, you can evaluate it this way. You can evaluate it looking at the graph. You can also, if you typed it into your graphing calculator, like if you type this function in, so x to the 3rd power, and then minus 3x squared plus 2. And then if you just looked at the table, you can also like look at -1, see it's at -2, and look at 0, it's at 2, and then look at 2, it's at -2. So I showed you 3 different ways that you can evaluate the function. Same thing here. You can do the exact same thing. You can look at the graph. You can evaluate it. You can look at your table. So at -1, so at x equals -1, the function is up here at 4. At 0, the function is at 3. At 3, the function is at 0. So it's very fast to evaluate it if I give you the graph. Find the domain and the range. So domain, remember, is your x line. And so the domain, and notice it goes from -4 all the way to 4 with brackets, interval notation. The range is your y line, so how low does it go from the lowest to the highest? Closed circles. That's your domain and your range. Now again, this is the exact same thing, just a different graph. So here at -2, when x is at -2, where is the function at? You can see it's at 0. At -1, it's down here at -1. So at 1/2, notice it's right here at 0. And at 1, it's down here, it's right here at -3. Your x's, so when x is at -1, when x is at 1/2, when x is at 1, where is f of x? To determine the intervals, oh, by the way, excuse the numbering. I got these problems from a certain page, and I think it's better to do it in a certain order. So the numbering, like this is problem 8 and problem 9, so I just got them from a certain page, so they may be out of order of what. This says determine the intervals in which the function is increasing or decreasing or constant. So we've already covered this. So if we talk about increasing, remember we always read it from left to right. So if you're on a roller coaster, and then notice he's increasing. So he's increasing from -infinity all the way, again, until he gets to the top. That's when he gets to 0, when x is. And then he starts to decrease from here to here, he's decreasing. Again, on the x-line, it's based on the x-line, so from 0 to 2, he's decreasing. And then he's increasing again from 2, again, based on the x-line, increasing forever to infinity. By the way, increasing and decreasing is always parentheses. It does not include it, because when you're sitting here at the top, if you're at the roller coaster, you get to the very top, you're not increasing anymore, and you're not decreasing anymore, right at the very, very top. Same thing here. You're not increasing, you're not decreasing anymore, so it does not include that point. So here's a piecewise function. So notice you're increasing from there to there, and then you're constant from there to there, and then you're increasing from there to there. So you could literally do the same thing with increasing and decreasing. So increasing is from negative infinity all the way to 0. And it's also increasing from 2 to infinity. And it's actually, it's not decreasing, it's doing constant. So it's constant from 0 to 2. All right. Let's look at finding the zeros. So remember, zeros is when it, like literally if you graph this, I want to know when does it hit the x line. So if this was 3, 0. So whenever the y is 0, that tells me the x-intercept, okay? So we're literally going to put f of x equals 0, and then we're going to solve it. Same thing here, we're going to put 0 here. Put this equal to 0 as well. And then we're going to solve this. All right, so I set them all equal to 0. Notice here I factored, and then I can see that x equals negative 5/2 and 6. Here I factored. Notice the top, like this step right here, when will this equal 0? Well, it will only equal 0 when the numerator equals 0. So x minus 7 equals 0, x minus 2 equals 0, which means x equals 7 and x equals 2. Here, I basically just squared both sides and then solved negative 2/3 to be able to get to my answer. All right, the vertical line test, we've spoken this about, just to determine if it's a function. If I draw a vertical line anywhere, notice it only crosses at one spot. Draw another, it only crosses at one spot. So yes, this is a function. If I draw a vertical line here, it crosses at 2 spots, or here, it crosses at 2 spots. The next thing is the average rate of change. So you have this formula that may be new to you. So basically, f of x of 2 minus f of x minus 1 equals, or over x2 minus x1. Well, basically, the average rate of change is a code name, I guess, for slope. Find the slope, the average rate of change. So if I have a graph that looks like this, and I want to know the average rate of change. So if I had a function like this, and if I, pick this point and I pick this point, and I want to find basically the slope, the average rate. Like it may go above it, it may come down. Average rate of change is basically finding the slope of these lines. So rise over run, if you want to do it that way. How much is it rising? How much is it running? So notice this is basically y2 minus y1, because f of x is the same as y. So like literally I can put a y there, put a y there, put a y there. So this is just y2 minus y1 over x2 minus x1. So let's look at number 10. We don't need to do 10, 11, and 12, but if you look at number 10, so basically look at the XY chart. If I put, it tells me to put in x1 is 0 and x2 is 3. So if you put 0 in, you're going to get 15. And you put 3 in, you're going to get 9. And then you just find the average rate of change by doing, y2 minus y1. I'm going to get negative 6. And then x2 minus x1 get 3. So the average rate of change is negative 2. That's really what you're doing, is finding the slope. Determine if the function is even, odd, or neither. Well, how do you determine if it's either one of these two things? We've already gone over this as well. One way to do it is you could look at the graph. So this is your y line, this is your x line. And to see if it's symmetrical about the x line, y line, or the origin, but this is also to tell if the function is even, odd, or neither, and then describe its symmetry. Well, to see if something is an even function, so a lot of students get this mixed up. They make the mistake of looking at the exponent, and because the exponent is even, then they think it's an even function. Well, that's not what it's referring to. Or like they might look at this one and say, well, that's an odd exponent, so it's got to be an odd function. Well, that's not necessarily true. So let's look at the definition. So if I want to find out if it's an even function, even functions are symmetrical about the y-axis. Okay, so that's one thing you need to keep in mind. So one way what we could do to solve this, so to see if it's even or odd, we're going to literally put this equation, and we're going to put a negative x into the problem, and then we're going to evaluate it and see what comes up. So this is going to be a positive x to the 6th. This is going to be a positive x squared, and then but it's still x squared, and then plus 3. Notice we came up with the exact same equation that we started with. So whenever it does come up with the exact same equation, then I know it's an even function. Okay, and again, even functions are also symmetrical. So that's something to keep in mind as well. If we graph this, we can see that it is symmetrical about the x line. So if we look at this with the y line, think of, I said it earlier, but so y equals x squared, the normal parabola is symmetrical on the y line, and that's an even function. So again, if any function is symmetrical or is even function, then I know it's symmetrical on the y line. So I can literally flip it over on the y line. So let's go to the next one. So I'm going to literally replace this with a negative x. And if I evaluate this, I'm going to get negative x cubed minus 5. Notice that's not the same function. It's not, so it's not even. And if when you plug in a negative x and you get the negative of the function, so in other words, if notice that was a positive, and if I get negative x cubed and then a positive 5, if I would have ended up with that, then I know it's an odd function. So this is not even, or it's not odd. Then notice my next example here. If I plug in a negative x, you're always plugging in a negative x. So this is going to be negative x cubed, and this is going to be plus 5x. Notice this is not the same, but it's opposites. So whenever you plug in a negative x and you get the opposite, then you know it's an odd function. Odd functions are symmetrical about the origin. Okay, so here, if it's symmetric, if it's an even function, it's symmetrical about the y line, the y-axis, and if it's an odd function, it's symmetrical about the origin.